A bloom filter is a great way to keep balloons out of your face. Wait, no, I'm thinking of something else. A bloom filter is a super fast and space-efficient data structure used to check for set membership. The space efficiency comes at a cost, though. If you have a set of objects, a bloom filter can tell you that an object is definitely not in the set, or a bloom filter can tell you that an object is probably in the set, but it can't tell you that an object is definitely in the set. On top of that, items can't be deleted from a bloom filter, ever. Why would we possibly need a data structure that can only probably tell you if something is in a set? Let's construct an example. Let's imagine we need to be able to check if something is or is not an English word against the entire Oxford English Dictionary, all 300,000 words of it. At 1 byte per character and an average of 5 letters per English word, that gives us about 1.5 megabytes of data to poke through. A binary search through this list should take us about 18 string comparisons, but we can do better. We could store the whole thing as a tree, but we've already covered that data structure. What if we maintain a giant array of zeros, and then hash each word in the dictionary, and store a 1 at the location of the memory index of that hash? Well, this is great, but if there's a hash collision, we could find ourselves reporting that an item exists even if it doesn't actually exist. We could use a hash function that's unlikely to create a hash collision. The chance of a hash collision is incredibly low in MD5, for example. We just need an array with as many available bits as there are possible outputs from MD5. Just 4 times 10 to the power of 25 terabytes. Okay, maybe that's unrealistic. It's certainly a lot more trouble than just storing the original 1 megabyte database. So let's say that we let collisions happen sometimes with a much smaller hash. If we hash a word and find a 0 at that memory location, we know that that word can't possibly exist. On the other hand, if we find a 1, all we know is that our word is probably in the dictionary. It could be the result of a hash collision instead. So let's try to reduce the chance of a collision. Here's one way. Let's imagine that instead of running the word through just one hash function, we run it through a few different hash functions, and then set the bits at all of those different hash locations. Then, when we check to see if a word's in our filter, we run the same set of hash functions and check every location. If there's a 0 in any of the locations, this word was never entered into the filter. But what happens if we want to delete something from our filter? Well, we can't. We might accidentally delete a bit that some other hash function set, at which point we wouldn't be able to guarantee that a 0 means this value definitely doesn't exist anymore. So if 1 or 2 extra hash functions is better, why not use dozens of them, even hundreds of them? Well, there's such a thing as going overboard. If we set too many bits in our array, the chances of an unwanted collision start to go up again. There's a sweet spot based on the number of items we're planning to put in the filter and the acceptable probability of a collision. We can determine the optimal bloom filter size and number of hash functions to use using mathematics. If we hit up a bloom filter calculator and tell it we have 300,000 entries in our Oxford Dictionary, and we're only willing to accept a false positive 1% of the time, it tells us that we need 7 different hash functions and 351 kilobytes of space. That saved us a lot of computation time and space. A common use case for bloom filters is to check if something doesn't exist before making an expensive call to find it. Google Chrome, for example, uses a bloom filter to flag malicious URLs. If a URL is flagged as potentially malicious by the fast, small bloom filter, then it's worthwhile to spend the time to make a much more expensive call to find out the details. A bloom filter with k hash functions and a inputs is called a ka bloom. No, that's wrong. I'm thinking of something from comic books. That's bloom filters. Thanks for your time.